All right. Thank you, Nicole. Welcome, fellow Conservation District employees, NRCS employees, other state agency staff, anybody else that I'm not aware of. Welcome to everybody. And just before we went live, I asked Nicole to give me a word to incorporate into this presentation, something to keep it a little bit interesting, keep me on my toes. The word she chose is puzzle. So look for that to be incorporated into this session. And I'll have a word of the day for the presenters in other sessions after this one. So I guess I'll do what Nicole said and give a brief introduction of myself. As she has mentioned, my name is Ryan Bartelheimer. I started work at Snohomish Conservation District in 1994. I worked at Snohomish Conservation District for about 15 years. In 2009, I went to the private sector. I worked for 2 different consultants and then came back to Snohomish Conservation District 2 years ago when the gentleman named Kelly Gahill that took my place retired. So altogether, I've been at Snohomish CD for 17 plus years, and the cluster that I serve includes Snohomish, King, Pierce, and Clallam conservation districts. I have a degree from Washington State University in agricultural engineering, and I think that's enough. I'm going to jump right into this presentation. It's all about fish-friendly drainage pumps, and I'll talk a lot more about the specific applications in general. And again, feel free to use the questions box to queue up any questions that come up, and there should be plenty of time at the end of this for Nicole to feed those to me. So I look forward to that. All right. Farmers, agricultural producers, they typically don't have unlimited resources. When it comes to drainage of their farm, of their operation, they typically rely on gravity as much as possible, which is free, obviously, but what's the cost of that? In a situation where the outlet, like in this picture, a tide gate, is into a river or an estuary or a slough, especially if it's close enough to receive a tidal signal where the water fluctuates, whether it's from tides or from rivers running high during flood season or as the snow melts, that gravity drainage can be not quite as reliable or predictable as the farmer needs to provide the water table control in their drainage system. And that's when a pump might be handy. I think I have a drawing tool here. When I clicked on that, all of a sudden I'm seeing myself. In this picture, there's a pump outlet right here and another one right here. This is a pump station in Duval. The agricultural area is on the other side of this pump station in this photograph, and these slide gates are in the up position to allow flooding to come into this area during the winter. And sneak peek, that's in large part why fish-friendly pumps were retrofitted here, is because a lot of fish ended up in the agricultural drainage system. And there we go. And here's a map of this area. The river flowing from south to north here is the Snoqualmie River. This red outlined area is the approximate area of drainage that feeds into creeks and then into the ditches and then through the pump station right at this intersection where it meets Cherry Creek. And in addition to fish ending up in this drainage system from floods, there are fish that swim through the tide gates and then spawn in these creeks just north of the city of Duval, which is in this picture. Long story short, we chose a couple of fish-friendly pumps to install at this pump station. This is what such a pump looks like. Its main use is actually in the sewer lift station. The reason for that is, or the sort of the design premise is that it has a single leading edge to the impeller, and it's designed to pump solids. It's designed to pump rags and ropes, pretty much anything that might end up in a sewer system, whether on purpose or accidentally. This pump is designed to send it through without chopping it, without grinding it. And if you spooled a 100-foot length of rope through this pump, it would just go right through. This is what these two pumps look like after they were installed at this particular location. They're submersible pumps, which essentially means that the motor that drives them is attached to the pump, and it and all of the connections are watertight and they can be inundated. And one thing that's unique about the impeller in this sewage pump is that for fish applications, the impeller is shrouded. In a sewer application, as the pump impeller turns, there's a leading edge that sweeps against the fixed part of the pump. And in the fish-friendly pump, you don't want that sweeping edge, a place where a fish can get impinged and essentially a point of danger for them. So what they do is they take the same impeller but weld a shroud on it so that the entire space that the fish and the water would go through is, there are no points of leakage or places where fish or water could leak out. And this is part of the puzzle of these pumps, is to come up with a type of pump that originally served a different purpose but has been adapted into being a fish-friendly pump. I'll have another type of example later on in this presentation. This is a view of the control panel that's opened. The main thing to note here is that there are master controls and then controls for each of the two pumps. Plus, you can't see it, they're behind this open door, but there's a control system that allows you to fine-tune the speed of these pumps. And again, more on that in a little bit. These pumps sit on a concrete base. I showed you the as installed view of them, and most of this base was underwater, but this is how they're mounted. I'm going to back up just a little bit and talk about where and when fish-friendly pumps, I think, are appropriate. It's number one, a drainage situation. A situation where you've got a drainage district or a flood control district, or maybe just an individual producer or a small conglomeration of producers that have drainage challenges. And also, it's a situation where fish are present or could very well be present. Another thing to note here is how sort of crusty looking this head wall, this pump station is. It's a sign that it's been installed for quite some time. And this is pretty common. These drainage districts have infrastructure that can be decades old. In fact, I'm working with a system right now that, to the best I can tell, was originally installed in 1936. 1936, and it's the same pump that was originally installed back then. So a lot of times these pumps are getting to the end of their useful life, and there are permit challenges to being able to just replace a non-fish friendly pump with another non-fish friendly pump. A lot of times when you go through the permit process, state, local, federal permits, they want to see things improved for fish. And that's where these pumps help out. And as an aside, one of these tide gates at the same time was replaced from being just a standard top hinged passive gate to one that was side hinged and operated on a float system. What that did is it let the gate open and essentially stay propped open until the water level rised on the outlet side to an elevation that would cause problems in the drainage district, and then it would close. So the idea was to have a much more passable tide gate, and in combination with that, replace the existing pumps, which are not at all friendly to fish, and make them fish friendly so that this whole pump station could be more passable by fish in both directions. And again, this brings up the point, whether it's in a setting like this, in a major river valley, or whether it's farther downstream in an estuary, it's a competition for limited resources. A lot of very productive agricultural areas, especially in Western Washington, are also areas that are targeted for fish habitat restoration. And these fish-friendly pumps are a great solution to try to make agriculture and fish use more compatible. In other words, let the agricultural operations continue, but look for ways to improve the safe use of these areas by fish. One thing that's always a problem in these agricultural drainage areas, particularly where there's a pump, is that it's essentially a dead end. You can end up with debris there. In this picture, there's some canary grass that had floated in. There's some apples floating there, but that was, they didn't just float in by themselves. But you can end up with sticks and logs and all sorts of things. And I'll come back to the debris in a little bit, but this is one thing to consider when looking at the possibility of a fish-friendly pump. And by the way, these pumps will handle solids up to about 40% of the size of the discharge pipe. These pumps have a 12-inch discharge, and the size of a sphere that would go through is about 5.5 inches. And also, just to recap, these fish-friendly pumps are most relevant where fish are known to be present, or they could possibly be present. And there's that slide. End of slideshow. Oh, somehow it jumped to the end. Okay. The other thing to note, if you did not have a fish-friendly pump, is you would, and if you had fish present, you would be trying to figure out how to exclude fish from that system. It's not easy to do, not easy to maintain. In this picture, this was a temporary approach to try to keep fish out of the non-fish friendly pumps. And I think there were problems both with debris and with beavers chewing on them. This is a picture of a completely different type of installation. This is the same, almost the same size of pump. It has a 10-inch discharge and inlet, but this is actually a food pump. This pump is actually most commonly used to pump whole foods such as potatoes. But this is a pump station, quite a massive pump station that has two 150 horsepower drainage pumps and four 450 horsepower drainage pumps. Those drainage pumps are all screened off, and the screens direct fish into kind of a funnel that then feeds this pump. So there are two small-ish pumps that are designed to pump juvenile fish downstream so that they don't have to go through a big drainage pump. This is a view of the motor that drives this. So instead of, as in the other picture, the electric motor sitting right on top of the motor and the whole thing gets submerged, in this setting, the motor sits adjacent to the pump and there's a belt drive system that runs it. Another important point about these fish-friendly pumps is efficiency. They're not necessarily quite as efficient as other pumps can be at their best, but it's important to note that these are efficiency curve numbers. This is just a generic pump curve. And what you want is for these fish-friendly pumps to be operating in this sweet spot where the efficiency is as good as it gets, because that will result in the most gentle handling of the fish, or in the case of the food processing pump, of food like whole potatoes. And in order to get the pump operating in that sweet spot, you first want to select a pump that generally is a good fit. But it's also a really good idea to install a variable frequency drive. This box up here is the variable frequency drive, but there's a control panel that was installed low enough for the operator to use it. And this is the variable frequency drive that operates this pump. I've mentioned when and where fish-friendly pumps are appropriate, but it's also important, I think, to mention that these type of pumps are not appropriate on irrigation withdrawals. What would be the point of safely pumping fish into a system that's not safe for fish? You don't really want to try to shove fish through sprinkler nozzles. Why a fish-friendly pump? I've covered this quite a bit. Keep the fish safe, provide the agricultural drainage that's needed, address inefficiencies or non-fish friendliness of an old system. But another point about this is to move juvenile salmon or other fish in a direction that they're trying to go without delay. This pump station design originally included a screen to keep fish out of it. But when the state and federal agency staff reviewed the fish screen design, and I recounted with them the timing of the pumps running and the timing of fish moving through the system, the agency folks said, you know what, these fish are better off without the screen. Let them take their chances going downstream through these pumps rather than keeping them safe, but keeping them out of the pumps and have them banging their head against these screens, trying to go downstream and being delayed. Also, again, these pumps are not chopper pumps. If there is some debris that comes through, generally will pass right through. But we definitely want to avoid having major debris go through. So coarse screens could be appropriate. And part of the strategy for that is a 6-inch clearance between the base of this concrete pad and the bottom of these pumps. And if you think back to the beginning of this presentation, there's sort of a trumpet bell shaped cone on the bottom of these pumps. And if you imagine a stick or something else trying to get in there, it has about a 6-inch gap, plus then it would have to make the corner. So this whole system, by its design, is fairly resistant to anything getting in there and causing problems. Also, as part of its lineage of being a sewage pump, there are these fast out assemblies that I didn't really point out, but essentially what this enables is these pumps to be deployed and pulled out rapidly. There are stainless steel cables that are coiled up in this picture. And if you imagine a sewer lift station and a pump having a problem, you're not going to dewater the whole vault, pressure wash it, get in there and work on the pump. You're simply going to hook onto the cable, lift the thing out, put it in a sealed truck, and go deal with it someplace else, and hopefully drop another replacement pump in. So they're very quick to deploy and pull out if you need to do any sort of work or maintenance on them. And at this point in time, I will ask Nicole to harvest any questions that people have. And
yeah, folks. Yeah, thanks, Ryan. So yeah, I'll just remind people to put your questions. You can type them right into the chat box, please. And or if you've got a question you would just like to ask, please raise your hand. So just hit that little hand button and I can unmute you, and then you can unmute you and you can just ask your question directly to Ryan. So please get your hands raised, put those questions into the question box. Looks like we've got one in there, Ryan. Eric asks, how much does one of these pumps cost?
These particular pumps that are in this picture are about $100,000 a piece. And that's for pretty much what you see, the pump and the fast out assembly, and for the parts that go with it. It was quite a bit less than that, about half of that cost 14 years ago when these were installed, but the current price is about $100,000. I will say though that the food type of pump, which is going to be much more rare to find an application where this would work because of its dry location, these are a bit cheaper. In fact, this one in this photo was actually refurbished, and we purchased it for about $25,000.
Okay, folks, please feel free to raise your hand or put any other questions into the question box. We've got another one from Dakota. Are these fundable through Equip?
I've not funded any through Equip, but I have funded these projects through a number of different sources, federal, state, and local. And I'll pull these off the top of my head. Back in 2014, that pump station retrofit was 2/3 paid for by FREMA, Fisheries Restoration and Irrigation Management Act, which was through, I believe, U.S. Fish and Wildlife Service. NOAA chipped in some funds for for monitoring and recording water levels and temperatures and so on, really to monitor the effectiveness of these pumps. We used something called the Pioneer Grant back then. I don't know what the equivalent would be now. National Fish and Wildlife Federation funds, King Conservation District assessment funds at that time. Currently, King County Flood Control Zone District funding works. Recently actually got commission funding to help pay for that pump in the dry well. For public agencies, the cost share rate is much lower. It's 50%, but that is viable. And that's one of the things about these fish-friendly pumps, is that there are a number of different funding sources that could very well pay for it. Floodplains by Design grants, those by their own nature are multifaceted. Fish benefits, farming benefits, flood reduction benefits. These fish-friendly pumps fit right into that equation.
Okay, Ryan, we have another question from Eric. What is the expected lifespan of these pumps, and have there been any issues with unforeseen maintenance issues?
The expected lifespan of these is quite long. The two pumps that were highlighted in this presentation, the blue ones, have been in for 14 years. And especially given that they're run seasonally, those pumps are run anywhere from 4 to 6, maybe 8 weeks out of the year. Most of the time they rely on gravity. The application for this pump is a bit different in that there is a window of time during the year when this flood control district is required to run these pumps. And I believe that's March 1st through the end of June. So this pump runs 24/7 for several months at a time. As far as maintenance goes, there's really not a lot to do. In both cases, it's really about making sure that the appropriate level of oil is inside. And in the case of these blue pumps, they have a moisture sensor, so that if water gets inside of it, it will turn on a light, a warning light on the control panel. And also there's an overheat, a temperature sensor essentially. So if the pump overheats, it will shut down and alert you to that. But other than one pump, neither of these two, but the similar model at a different district, essentially was not properly assembled. They hadn't fully torqued down the bolts between the motor and the pump body, and everything started up fine. But after they used it for a little bit, there was some wobbling, and essentially some excess heat was generated, and it seized up. But that turned out to be essentially a manufacturing defect, and that was fixed. And to my knowledge, there have not been any major problems with any of these pump installations that have been in this case from 2004, and a different district 2006. They continue to work pretty reliably.
Okay, we don't have any other questions immediately in the chat box or questions box, but folks, please enter those in, or at this time, just feel free to raise your hand. I will unmute you and you can ask your question if you've got it. Okay, I'm not seeing anything come in at the moment, Ryan. But I'll give folks a moment if they've got anything else. Okay, you were pretty quick, Ryan. You still have a lot of time left if there's anything else you want to cover.
Well, I can talk a little bit about upcoming presentations. The next one up will be a presentation on treating barnyard runoff using a vegetative treatment area. And I'll wait until that speaker shows up, but he's a highly qualified engineer who has designed a bazillion, literally, rain gardens and other sort of roof rainwater harvesting catchment systems. But in this application, he modified his design to take the organic loading that you might experience from a barnyard. There are a lot of crossover tracks, both today and tomorrow, and other other things that might be of interest to people that are on this presentation include low-tech process-based restoration and bioengineering, which is coming from the riparian restoration track, crossing over into the engineering. We've got a session this afternoon on using or developing projects that benefit both fish and farming. And then tomorrow, we'll be crossing over the engineering and farm and field tracks to look at irrigation technologies and efficiencies. So Nicole, hopefully you caught my use of the word puzzle in my presentation, and
I did.
I will throw out a word of the day for future presentations. Yes, go ahead.
That's great. I will say we did get one more question that came in, Ryan.
Yeah.
So Dakota asks for irrigation systems, screens would be used instead of these fish-friendly pumps. Is that correct?
Yes, for irrigation systems, I'm going to take a second and go back.
Yeah, let me make you the present. Yeah, hold on one second. I took it back just for a second, but here you go. It should be right back over to you, Ryan. You can share your screen now.
Okay.
There you go. Great.
Let's go. Oops. For irrigation systems, the premise is that you have a large water body or water course with water flowing downstream. And irrigation withdrawals, such as this one, that are screened off, there are some key things to make it work. Number one, you typically don't want it on the riverbed. You also don't, you want a certain amount of water both over and under the screens. I can't vouch for this particular one, but then you also have a sweeping velocity, so that the water, there's most of the water, the vast majority of the water flows by and goes downstream of an irrigation withdrawal. The screen is there to keep debris and fish out of your irrigation system. And part of the design of these screens is to have enough surface area that the approach velocity to the screens is so low that even if a fish was curious of what the blazes this thing is, it's not going to get impinged, sort of sucked up against the screen and not be able to leave. So this is a very different application than these fish-friendly pumps in a drainage situation where everything is going to the pump. So that's why there are screens on irrigation withdrawals, and that's why it's such a challenge if you were to try to use a screening system on a fish-friendly pump.
Okay, any other questions for Ryan? Got another one. Good job. Dakota asks again, do you have experience with agri-drain water control structures and how those might apply?
Yes, and so I presume that you're talking about some sort of water control structure at the outlet to a drain tile, something like that. Is that what you're getting at,
Correct.
Drew? Yeah.
Yes.
I don't have a lot of experience with that, but there's a project that is due to be constructed this summer with such a device. There's a field actually very close to this pump station that has a depression in it, and essentially the landowner has essentially turned it into a hunting pond to attract ducks there in the winter. And there's a pipe outlet that goes from there to one of the drainage ditches. And he's working with Ducks Unlimited and the county to do maintenance on the drainage system, and as part of the overall upgrades of putting a drainage control structure near the outlet of this drain tile that's also a surface water outlet for this pond. And the idea is to use it to raise the water elevation in this pond, but then also when it comes to springtime, keep the water in the pond maybe longer than he normally would, and release that water in such a way that it helps provide more sort of base flow in that drainage system to benefit the fish. Does that answer your question, Drew?
Yeah, that was Dakota. I think it does.
Or Dakota?
Yep, she said, thank you. That's great.
All right,
Okay, any
thanks,
other
Dakota.
questions? You guys can, I mean, you have time. You almost have like an open question forum for Ryan. You can just chuck stuff at him and see if he can answer it.
Stump the engineer.
Yeah, yes, that would be fun. I dare any of you on the call, see if you can stump the engineer here. He's a great resource. You really have like open source to him right now with the time we've got remaining. So again, you can raise your hand if you just want to ask verbally on the phone. If that's a little quicker, you can take the time to type it into the question box. Okay, I'm not seeing anything pop up, Ryan. Looks like unless you just you want to add anything else, we might just end this session a little bit early, give folks a few minutes to go refresh and snack up for our 11 o'clock session.
Sounds like a plan. I guess I will just add to, in light of this presentation being all about fish passage, I hinted at my experience with different sorts of tie gate designs that allow fish to pass through similar type of structures, but in a passive way. They swim through. If any of you have questions or want details on those sorts of structures, feel free to reach out to me later.
We've got a good question that just came up. All right, Ryan.
Right.
Okay, so from Karen, Snohomish CD does a lot of floodplains by design work. Can you talk about the most common engineered BMPs that are used for ag producers as part of that program? More of an overview of the types of flooding related BMPs.
Okay. I'm involved in 3 different floodplains by design grants. 2 of them are in Snohomish County and 1 is in Pierce County. For all 3 of them, they're at the stage of, I would say they're beyond the planning stage and working toward the implementation stage of things. Uh, it really varies. They're kind of watershed specific, and I'll give an example. The Stillaguamish watershed is one in which the Stillaguamish tribe is actually the sponsor of that grant. And their approach has been, and sort of the projects that have come forward in the Stillaguamish Basin are ones that are more or less either fish centric or flood centric or farming centric. And specific examples are, complete restoration, taking a 100-acre sort of peninsula within a river meander that got just hammered in a flood about 10 years ago, and pulled the dike, made a little setback dike, and opened it up to fish habitat. But on the flip side is there's a project to basically fortify the sea dike that protects a drainage district. And then within the city of Stanwood, there's a stormwater project that basically provides more detention and retention and water quality treatment. So in the Stillaguamish Basin, the projects have been either almost entirely agriculture or fish benefit or flood benefit, and not a lot of crossover. Other areas have been more finding opportunities to do one set of actions that tries to blend everything together. And an example of that is in the Clear Creek Basin, the lower Puyallup. And there, nothing has, well, I shouldn't say nothing, there have been some early actions to do some drainage maintenance that has been a long time coming, essentially overdue. But the challenge there is that there are a lot of homes. The county has bought out a lot of these homes, and they're trying to figure out how to move a project forward that doesn't just wipe out and buy out all of the homes and farming properties, but reconnects the lower part of the Puyallup River into this drainage district, allows the fish passage, but also provides for agricultural drainage. And one of the, I guess, main ideas that I brought forward to that group is the idea of separating out fish habitat and streams from the ag drainage system. So you get away from the situation where you've got the farming area trying to have a gravity drainage through an area that you want to restore for fish habitat. Because in the long run, you want the fish habitat area to evolve based on what's going on, the tidal fluctuations, the river fluctuations, the sediment loads coming from the river, vegetation responding, wood being deposited. And all of these things lead to a less predictable outlet conditions for the ag drainage system. So if you imagine sea level rising, sediment aggrading, and so on, these are things that work against having a gravity drained agricultural system work. But if you separate it and have the agricultural drainage system not drain through the fish habitat, then it makes it so that if there are problems with water quality from the ag drainage system, it's not going right into the fish habitat areas. And also whatever evolution happens habitat-wise and water level-wise in the fish habitat area, that doesn't end up impacting the farming community. And of course, as part of the strategy for reducing the risk to the farming community, in addition to gravity drainage, adding pumps would seem like a great way to mitigate for the risk of sea level rise, changes in flooding regime, and so on. But we will go in the 2 to 3 o'clock session this afternoon. There will be more examples of kind of BMPs that are being viewed to benefit both farming and and fish habitat.